Number 15, we want to find the domain. This time we have a root or radical function. So we have f of x equals the 7th root, so you'll see that 7 there, 7th root of x plus 10, and then minus 5 outside of the radical. So per our discussion, I think it was problem number 12, we talked about the 3 problematic scenarios. One was a fraction, one was an even root. So you see how we have an odd, it has to be an even number to cause us an issue. And then we had a logarithm. Okay, so this problem does not have either one of those issues. There's no fraction with x in the bottom. It's not an even root. We do have a root, but it's odd. And then we don't have a logarithm. So in this scenario, you don't have to do any work. Your domain is all real, and it's just by knowing that definition in those 3 situations. So just negative infinity to infinity. So this time we want to find the domain, and they give us answer choices to choose from. This time the answers are not in interval notation, they are in set notation. So we'll work this one just like the others, but we'll get the stop before we have to change it to interval notation. All right, so we have f of x equals 3 minus x. And then we have x squared minus 9x. Okay, later on, this numerator will play a part in determining domain, mainly when we start dealing with asymptotes and things of that nature. But for now, it doesn't change anything. Still, we have fraction with denominator in the bottom. So we take the bottom, the denominator, and we set it not equal to 0. So x squared minus 9x cannot be equal to 0. We have to factor out an x. And then we have x minus 9 cannot be equal to 0. And then from here to find our domain, we have 2 separate terms. These are being multiplied. So if x is 0, this whole thing, when you multiply, is equal to 0, which we don't want. Or when we set this one equal to 0, we'll see if we get 9. So you have 2 parts. We have x cannot be equal to 0, and we set this part, x minus 9, not equal to 0. So you have to do both. And we're going to add 9 to both sides. And then we get x cannot equal 9 here, and we have x cannot equal 0. So in set notation, all they're doing is listing these 2 things. So they're saying domain is the set of x's such that x cannot be 0 and x cannot be 9. Okay, so you should be able to pick it out from those 2 once you see those. And it looks like answer choice B is the one that matches.